Hi everyone, welcome back to our daily LeetCode challenge series. So today is day 82 and today we are going to solve LeetCode problem 16, three sum clauses. Okay, so this is a medium level problem. So let's see the problem first. So we have given an integer array nums of length and an integer target. Fine. Find three integers at distinct indices in such that the sum is closest to target. Okay, return the sum of the three integers. You may assume that each input would have exactly one solution. Okay, understood. So in example 1 we can see like we have given a num array -2 to 1 -4 and target is 1. So we have to find the minimum sum or triplet of the three different indices whose sum is like nearby or equal to the target, right? So here if we see, let's say we are taking this three sum, so this will be having 2 and this will be having like 3 and 4, it will be -1. So we can say 2 is the nearby of this, right? Because -1 0 1, so this is far 2, right? But this is like nearby, so 1 is different, so this is a nearby function, so we are trying 2. In explanation we can say the sum of that closest to the target is 2, -1 2 and 1. So this triplet we are considering here, right? In example 2 we can see like we have only three elements, so anyways the sum of these three is anyways 0, and which is uh, like nearby target, and other than that we don't have any triplet combination here, right? So we are taking it as 0. So basically we are returning the sum, the minimum sum that is equal to the target or nearby the target, right? The sum that is closest to the target is 0, 0 plus 0. So yeah, that's what we saw, like, right? In the constant we can see that the given array's length can be ranged from 3 to 500. So there are possibility like of one solution for sure. Okay, based on the three size, and values can be vary from -1000 to +1000. Fine. And target will also from -10 to the power 4 to 10 to the power 4. Fine. So what we can do in this case, as we have to find the sum of three distinct values and nearby to target, so either we have to take the maximum value or the minimum value, so we have to consider both one, right? So in that case, like what we can do, we will first sort the array, right? So whatever the minimum element will be there, that will come in the left side and the max will go the right side. So we'll consider that minimum 3, or like we can take first values and last two values to find the combinations, right? Whichever is nearby to a target, based on that we'll move our pointer. So first we'll do the like sorting of the given array, and then we'll use two point approach to find another two index. So one will be fixed for sure from front side, and then other will I'll move the pointer to find the like nearby sum to the target or the triplet sum, right? So okay, so we have given the method three sum closest and we have the num array and the target. Fine. So what we'll do here, first let's sort the array. Okay, I think there's some issue. Fine, yeah. Okay, now we'll use arrays dot sort method to directly sort our given array, right? Now what we'll do here, as we have sorted the array, so this will basically take n log n time. As we all know, behind the scene it is using merge sort logic or quick sort logic. Okay, so that will take n log n. Fine, our array is sorted now. What we'll do after sorting, let's say min sum will say the sum of the like first three indices. So first three indices will say num of 0, nums of 1 and nums of 2, right? So this will be the minimum sum for sure, right? So what we'll check here, we'll have to run a loop. Okay, we'll start a loop from our index 0, that will always fix, and our I will goes till nums dot length minus 2, right? So it will go nums dot length minus 2, uh, okay, and then we'll do increment I plus plus. Now what we'll check here, we'll take 2 pointer here, right? Let's say I equals to nums of I plus 1, okay, and second pointer will take from, let's take from the like end of this array, right? So we can say nums of nums dot length minus 1, okay. And this is array, right? So we can directly go nums dot length, fine, okay. Now what we'll check here, we'll check if left is less than right. So in this case we will see, let's take in current sum. In current sum equals to nums of I, right, that fixed index, then nums of our left index and nums of our right index. So we are taking this, considering this triplet. Then we will see if our let's say current sum, okay, whatever we have got the current sum minus target, okay, is like lesser than whatever we have stored the min sum minus target. So in order to compare, what we'll do, we'll just take the absolute value of the difference, right? Maths dot abs. Similar way we'll take for this as well, maths dot absolute. It's not maths, it's math dot absolute, right? So yeah, this way we will check if it is lesser than, so we'll update our value of the current sum. So current sum will main sum will updated with the current sum. So that is the minimum sum that we are going to basically return, right? Now based on this we will have applied. Now we'll check, let's say if our current sum becomes equal to target, right? What we'll do here, I will simply return the current sum, right? Because that is the minimum one after the getting the triplet sum nearby, we can say. If not so, then we'll see if our current sum is greater than whatever we want target. So if the current sum is greater, that means we have to do the like decrease the number, right? So decrement, the greater number is always in the right side because we have already sorted. So what we'll do, we'll just do the decrement from right side, and if it is not so, then we'll just do the increment from the left side, because we have to get the greater number, right? That's why. Okay, this is how it will be, and after each iteration we will got the value, the minimum sum, and at the end, okay, I will just return min sum. Okay, so let's see if it is closed. Fine. Okay, now let's submit and see the test cases. Okay, we have got array index out of bound at line here. Okay, so we have taken the value of this index. Basically we have to take the index itself, that's why it is getting out the index, right? So it was my bad, so fine, that's why it is giving array index out of bound, because it is taking the value. So value is till 1000, so that is like mostly this case is correct only in that case, that's why. So I have removed that part, so we have just taking the index now. Now let's submit and see. Hope it will work now. Okay, so yeah, our both test cases got accepted. Fine. Now let's submit and see other test cases as well. Okay, yeah, so all 107 test case got a passed and it beats 93%. That's quite good. Fine. So yeah, if we talk about the time complexity here, so basically we are doing the two things here. First we are sorting this array and then we are iterating over each element, right? And even we are doing the while loop inside that to check the triplet sum, right? So here it is taking n log n as we say, and here it is taking big O of n square. So among this the time complexity will be big O of n square here, and space complexity is constant because we are using one constant space. So yeah, so space complexity is big of 1 and time complexity is big of n square. Yeah, so that's all. So if you know any other approach other than this, so I think this is the optimal one that I know. If you know any other approach other than this, then you can comment it down. So that's all for today. Let's see you next video. Bye.